Hello, I'm Chun Wang from University of Luxembourg. Today I will show you UMTG. UMTG is a toolset to automatically generate system test cases from use case specifications. This work has been developed under the context of a collaboration between SNT and IEE, which is an automotive company. Let me first introduce the feature of the tool. UMTG can automatically generate the system test cases from use case specifications. At the same time, it can capture and create traceability informations between test cases and the use case flows. Now the UMTG integrates with IBM Doors, which is a requirement management tool, and IBM Rhapsody, which is a modeling tool. The strategy used by UMTG are the following. So first, the UMTG relying upon a restricted use case template, and then automatically extract the test model from the use case specifications. And finally, use the constraint solving to generate the test inputs. UMTG generates a test case for each scenario of the use case specification and only required minimal modeling effort. Let me introduce the workflow of UMTG. The software engineer starts by elicit the use cases by adopting a restricted use case template. And then the software engineer needs to provide a domain model of the system. A domain model is used for clarify the concept which in the use case specifications, and the domain model is in terms of class diagram. In the third step, UMTG can automatically extract a list of conditional descriptions from the use case. This list of conditional description need to be specified into OCLs by the engineers. Then, by combining the natural language processing and constraint solving, UMTG can automatically generate a set of abstract test cases. Abstract test cases is the test case whose inputs are defined as the instance of the domain entities, so it can't be executed on the system. So in order to generate the executable test cases, UMTG used a mapping table and can automatically translate the abstract test cases into concrete test cases. In the following demonstration, I will use a simplified version of our case study, which uses our experiment. The case study is BodySense. BodySense is an embedded system for detecting occupancy status in a car seat. BodySense is developed by IEE. So let's move to the demo. Now the screen shows the IBM Doors, which contains the use cases of BodySense. The use cases are written according to the RUCM format. RUCM is a restricted use case template, which includes a set of keyword and restriction rules. So we can see that the words in capital letters are the keywords. For example, the validity set in the step number 4 and the send to in the step number 5. So let's first take a look at the basic flow of the main use case. So we can see that the system first requests the weight of the driver from the seat sensor, then do the self-diagnosis and also classify the occupant status. Then in the step number 4, the system will validate that if there's no error is detected. So this is a conditional step. If this condition is true, so then the system will send the occupant class to the airbag control unit. And the post condition of the flow will be the occupant class has been sent to the airbag control unit. So if the condition in the step number 4 is false, means there some error is detected. So then the one of the specific alternate flow will be taken. So then the system will send the error occupant class to the airbag control unit, then abort this flow. And the post condition will be the error occupant class has been sent to the airbag control unit. After the engineer finishes specifying the use case, then they can use the the plugin UMTG plugin for doors to create a UMTG project. The UMTG project is used for the test generation. Now the tool will ask where to put the project. So then we select the path and create a new folder called demo. Now let's move to IBM Rhapsody. So here we open IBM Rhapsody with the modeling project of BodySense opened. The engineer can use the import function to import the UMTG project into the workspace. So we just select the project we just generated and finish. So now the project has been imported. So now the engineer should provide a domain model of the system. So let's take a look at the domain model. So we can see that the body sense system connects with several sensors like seat sensor and temperature sensor, and also is connected with a bunch of errors. The connection with occupant status is indicated the current occupant status of the seat. Once the engineer finishes the domain model, they can use the plugin for Rhapsody to export the model. But it takes a little bit of time. So I already exported the model before, so I just copy and paste it under the models folder. Now the engineer can open the conditional.ocl to start specify the condition into OCL. So the conditional.ocl contains a list of condition description which automatically extract from the use case. So let's open it. So for example, we have the condition temperature is valid. So this is corresponding to the condition in the use case. So we can find it in the use case. Yes, it's in the step number 3. So the system validates that the temperature is valid. So according to the specification, the working temperature of the system is between 0 and 45 degrees. So I have already specified all the conditions. Then I just copy and paste it. So we can see how the temperature is valid is specified. So it's between 0 and 45 degrees. So once the engineer finished editing the OCL file, so then they can use the function provided by UMTG to start generate abstract test cases. So then the tool will ask which use case to generate test. So we just select the main use case. During the test generation, let me explain how it works. UMTG first generates a test model for the use case specifications. The test model captures the control flow information of the use case and allows to identify test scenario. A test scenario is defined as the flow begin with use case start node and ended with the exit node. For each of the test scenario, UMTG will collect all the OCL constraints connected with the conditional node, and then invoke the OCL solver to generate the test input. The test input is an instance of the domain model, which satisfies all the conditions through the scenario. So once the abstract test case has been generated, a folder called ATS will be created. So from that, we can open one of the abstract test cases to see how it looks like. So to keep the readability of the abstract test cases, it first contains a header section, which explains what's the scenario under test. For example, this is the scenario that the temperature is valid is false. So then the system will set that temperature error as detected, And as a consequence, since there's error detected, then the system will send the error open class to the airbag control unit. The body section will contain a list of test steps, which explains how the test input are set and what's the oracle need to be checked. So from this example, we can see that the input of temperature has been set as 48 degrees, which is higher than the 45. So then the oracle need to be checked is the temperature range error has been detected, and also the error occupant class has been sent to the airbag control unit. We can see that these abstract test steps are defined as the instance of domain entities, which can't be executed on the system. In order to generate the executable test case, we need to ask engineer to provide a mapping table. Here is an example of the mapping table. Mapping table explains how the abstract test steps map to the test driver functions and the parameters. For example, the input of temperature will map to the test driver function set bus, and the value of the temperature will map to the parameters of this function. So we need to put the mapping table under the ATS folder, and the engineer then can use the function provided by UMTG to generate the executable test cases. The executable test cases will also generate into IBM doors. And this is allowed to also generate traceability links. The traceability links will point to the flow which under tested by the corresponding test case. So let's open IBM doors. Executable test cases will be generated under the folder system test cases. Now the executable test case has been generated. Let's open the generated test and see how it looks like. This is the example we showed it before. Similarly, the executable test case also contains header sections which explain what's the scenario under test. In the body section, it contains a list of test driver functions which need to be invoked. So we can also see that to set the temperature as 48 degrees, the driver function set bus will need to be invoked and with the value of the 48 degrees. And to check the temperature error has been detected, we need to invoke the lin publish and also check the error code. From the header, we can also see that there's a small arrow here. This is the traceability links has been generated by UMTG. If they click on the traceability link, they can go directly to the flows which tested by the current test case. This is a demonstration of UMTG. If you are interested, you can visit the following website. Now the UMTG is available for download. You can download and try it. Thank you for listening.